Welcome everybody. We're about to start. Welcome to the new era, not the end of the world. The world did not end. So you're stuck with me for another year. What can I say? Thank you. I'm glad we're here. I'm glad the world didn't end. I've still got too many things to do. No time for end of the world business. But we have a very full meeting tonight. So welcome everybody. Members new and old, and I know there's a few faces in the crowd that haven't joined us before and are here for the first time, so welcome to you as well. I hope you enjoy what we've got. We do have a very packed program tonight, so I won't spend too much time babbling. Where are we here? Oh, there we go. Let's see. There we go. We had to throw that one in. Yeah. He does look a little sad that it didn't come to pass, eh? Yeah. Tough on him, too bad. So we've got this is our program for this evening. We've got Gary Boyle, and I have to do my Gary Boyle impersonation because he's not here. We've got Gordon Webster going to talk to us about astro sketching. Chuck's going to give us an update on the meteor craters that he talked about recently. Then we'll have our break, door prizes. Then Pierre and Ramon are going to show us some really awesome imagery that they captured of the Geminids. Of course, those guys like to travel. They went to a warmer place to catch an awesome view. And from what I saw of the slides, well worth the trip, like awesome work. And then we've got Glenn LeDrew. And for those of you that have read your recent issue of Sky News, you'll see some excellent charts in there done by Glenn LeDrew. And he's going to talk to us about how he in fact creates them. And then of course we have our usual observations. We've got some interesting imagery there, and I think that will pretty much take us through to 10. All right. Before we get into all that good stuff, we do have a few members in the news. There we go for our calendar. Do we have any calendars left, by the way?
6 left.
We have 6 left. Okay, you have to save me one of those. I didn't actually get one last month, but in the current calendar for the RASC, we have this wonderful image of the Horsehead and the Flame Nebula by Peter and Deborah Saravolo. It's also the cover image on that. So well done, a nice, a beautiful piece of work. Yeah, round of applause to all. Absolutely. Then this one, we've actually seen this one in the fall from our collection of planetary images. I know that we had Rolf, get our laser going here. There, Rolf did this excellent work of Jupiter, and including this is one of the best I've ever seen of details on the moon. And I think it was was Ganymede? Yeah, Ganymede. That's right. So that also appeared in the latest issue of Sky News. A beautiful piece of work there. One of the nicest images of Jupiter I've ever seen. So again, Rolf, not sure if Rolf's with us, but an excellent piece of work. Mountains on the Moon. Mike Wirths, he's still with us. He's down in Mexico somewhere, but he's still with us and sends us the imagery there. And again, made Sky News there. A beautiful lunar vista there, and up to his usual superb level of detail. Makes you feel like you're right on top of it. So
probably needs a couple of lessons on how to do that right, doesn't he?
Yeah.
How to get focused.
Yeah. Yeah, it's a little soft in places, right? Yeah. I can only see down to about 500 meters resolution on this. So. Yeah. Nice work, Mike. And of course, this issue of Sky News is just chock full of things. And as I mentioned, Glenn LeDrew's excellent work there on the history of the stars in the Orion constellation and area. So Glenn is going to talk to us about how he actually creates these beautiful charts. Nice work, Glenn. All right. Without further ado, I now put on my Gary Boyle hat. So Gary he was going to be with us tonight, but Gary's wife, as it turns out, has come down with a rather nasty case of the flu, and Gary did not want to leave her alone. So, a collective, how to go, Gary. Good stuff. All right, so I'll do my best. I just had a quick look at this when I came in there. We'll talk about what's happening in the sky right about now. So prominent in the sky, of course, at this time of the year is the constellation Orion. Glenn will show us a bit more of that. But certainly, if we do get some clear skies at some point, which they're promising for the next few days, Orion well worth looking at. There's such a richness of targets in Orion that you can spend a lot of time, certainly more time than the sky gives us, to explore it, and it's just a really cool area to check out. Currently, we have Jupiter up near Aldebaran. If you've been watching Jupiter's progress, it's moved along quite nicely there, and it's now above the Hyades cluster there, between the Pleiades and the Hyades. Very, very prominent. He's got a few areas circled of interest there, a bit of a close-up on the Hyades there as well with Aldebaran, easy to find. And Jupiter, very easy to find. It's nice and bright in that Jupiter just passed its opposition a little while ago. So it's a nice bright target, and of course then there's the Pleiades just a little bit above that as well. So the Pleiades and the Hyades, of course, just a bit of background. These are the closest to open clusters to our place in the galaxy. The Hyades cluster is only about 153 light years from here. It comprises the bulk of these stars. Aldebaran is actually not a part of that cluster. It just happens to be in front of it. It's actually a fair bit closer than the other stars in the Hyades. And we have the Pleiades at 430 light years, distant, about 3 times the distance of the Hyades themselves. And just for your reference, again, because we're looking at something that's 3-dimensional, we've got Aldebaran at 65 light years, the Hyades at 153 light years, and the Pleiades at 430 light years, and old Jupiter there just at 43 light minutes away. So gives you a sense of that perspective there, right next door to us. All right. And of course, in any small telescope or even a good set of binoculars, you're going to see a detail in amongst the prominent stars of Orion. Certainly, everybody is probably familiar with that region of the sky containing the Orion Nebula, of course, and M43 as well there. Also up here, just off the belt stars of Orion, we have the Horus Head in there, and we have the Flame Nebula as well. The Horus Head, you need a larger telescope to see. The Flame Nebula is a whole lot easier with a more modest-sized instrument, but a really beautiful nebula. Again, just reading his notes there, he says it's less than 1 million years old. Okay, that's good. January 21st. I don't know if many folks got out to see the opposition or the conjunction between Jupiter and the moon Christmas night. And of course, you might have had a few other things on the go. We do have a couple of observations from that night there, but Jupiter was at a comparable distance to the moon on Christmas night. And as it turns out, it was clear. So it was really kind of nice to see, because especially given their proximity, you could see that right around the dinner time, if you did get out to see it, Jupiter was pretty much directly north or directly above the moon there. But by even later in the evening, by about 9 o'clock, 10 o'clock, you could actually see how much the moon had moved in its orbit and how much further apart they'd become. So another opportunity to check that out on January the 21st. It's well worth checking out, especially the motion. I found that was really cool, because I did get a chance to look at it a few times there during that evening there, and it was really obvious how the moon was moving along. So January 21st. Then we have that one, which I'm not sure what he was going to talk about, but correct me if I'm wrong, it looks like a bit of Gegenschein there. And, sorry? Zodiacal, yeah, and obviously a meteor there. I'm not sure where he pulled the image from, but nice image to look at anyway. And a summary of what's going on. Mercury in Sagittarius, obviously you're not going to see that at this time of the year. Venus also very, very low just before sunrise. Mars very low in the west. So yeah, the inner planets are certainly nothing too prominent at this point in time. Jupiter, if you haven't had a chance to look at it, have a look at it soon, because as I say, we're just past the opposition, and even a reasonably small telescope will reveal the major bands, and certainly the moons. And if you've got a really sharp eye and a clear night, you'll see the red spot if it happens to be turned towards us when you're looking. Saturn is coming back into the picture, rises around 2:30 in the morning. Uranus and Neptune, they're there. They're there, yeah. You need a fairly large telescope to see anything more than than little blobs there, but they are there, and they're fairly well placed for observations. So there we go. That's what's happening with them. The moon, of course, our phases, January 4th, first quarter, new moon on the 11th there. So next week we're moving into a moonless window, and they're actually forecasting for some clear nights Monday and Tuesday night there. So it might be an opportunity to get out and test out any new telescopes that some members may have received. Last quarter on the 18th, and of course full moon, the wolf moon, on January the 26th.
Excuse me, Paul.
Yes.
The phases are reversed. It's last quarter up at the top.
Oh, I'm sorry. Did I say that? Oh, I mixed them up. Sorry about that. Yeah, last quarter, I stand corrected, and first quarter. I'll get you for that. And hopefully Gary will be back next month, and you'll have to put up with him. So that's our summary of the Ottawa skies for this month. Here we go. Thanks to Gary for preparing that for us. All right. So without further ado, because we do have a fairly full program, we have Gordon Webster, and he's going to talk to us about astro sketching. Come on up. Good to see you. Oh, I should, before, I'm going to steal 30 seconds. Apparently somebody lost a hat in the hall there. So if this is yours and you want to claim it, or if it's not and you want to steal it, I'm going to put it right there. All yours.
And if you don't claim it, I guess it's an extra door prize.
Good, thank you. Yeah. Well, it looks warm anyway.
Happy New Year, everyone. Okay, so I want to talk about astro sketching tonight. For me, sketching what I see through my telescope is directly tied into keeping my logbook. I make notes of virtually everything that I look at with my telescope, enter the time, and a brief description of what I'm looking at on a pre-made log sheets that I have. I include date, location, observing conditions. If something holds my interest a little longer, then I'll write a more detailed description. And if it's something I find really interesting, or something that was challenged to find, then I'll do a sketch. Just as making detailed notes of an object forces you to pay more attention to the details, doing a sketch at the eyepiece forces you to look even closer. The result is you see more, and isn't that what we all want from our observing sessions? But you say you can't draw. Let me respond to that with a brief description about drawing. Drawing is a learned ability, like learning to read or ride a bike. I've never met anybody who claims they can't read because they weren't born with a talent to read. Everybody learned to read. Unfortunately, due to the way that our brain works, and the way we learn, or more accurately, the way we're taught, most adults still draw the same as they did as a child. Drawing is a right-brained activity. Astronomy, visual observing, is really a right-brained activity as well. We live in a left-brained world. This matters because of how the left brain stores information. One of the methods is to store visual information as symbols. A glove is a symbol for the hand. Stick figure represents a person. A lopsided or a lollipop-shaped shape is a tree. And the constellation Cepheus represents a house. Nobody's ever seen a tree that looks like a lollipop, but we all recognize that it means tree. The left brain is content to use this shorthand, and it actively discourages you from going any further. The right brain would rather spend as much time as possible investigating every branch, twig, leaf, whatever else it can find that defines this specific tree. How is it different from other trees you've seen? Which way does this branch go? How do the branches overlap or intertwine? Where are the holes for the birds to fly through? What's hidden by the leaves? We tend to think of drawing as something to do with a function of the hand, but it's not. Drawing is totally controlled by your eye and your ability to see clearly. As astronomers, you know that you can see more now through a 100 mm telescope than you could when you first started through a 200 mm telescope. It's because you've learned how to see clearly with an informed eye. You know what to look for in that faint fuzzy, and you know just how faint it's going to be. When you were starting, you were happy. Oh, here comes my assistant. You're happy just to find that dim smudge. And unless the detail was obvious, like a bright stellar core, it went unseen until you returned to it a few years later with some observing experience. This is exactly the skill that is needed to draw accurately. I'll provide you with a couple of examples of how to sketch something at the eyepiece. To keep things clear, I'm defining a sketch as something done quickly in 5 to 15 minutes. A drawing is a more finished work that, typically you can take up to an hour or more. It's something that you probably finish. You might start the sketch at the eyepiece and then finish it later in the warmth of the kitchen. So I'm going to do a star cluster, a galaxy, and then a lunar sketch. So we'll start with something that doesn't require any really drawing skills. I've selected M103. It's a fairly simple open cluster. There are only a few bright stars to deal with, and not a whole lot of faint ones. Okay, I have reproduced an eyepiece view from SkyTools 3, as seen through my 12-inch Newtonian with a 13mm eyepiece, giving a magnification of 115. That's figure 1. Thanks. Okay, so to complete the sketch, the only thing I'm using is a mechanical pencil. Okay, to start, imagine the eyepiece view as a clock, with 12 o'clock at the top and 6 at the bottom, 3 at the right, and so on. If you're using a circular template for your drawing, translating this view is easy. I typically will start by placing the stars near the edge of the field of view, figure 2. Okay, so this defines the outer limits of the sketch and of the view. If you're not using a motorized telescope, this frames everything so that when things drift a little bit, you can come back and place them as you have them in the initial sketch. Okay, so you're now free to increase your magnification to help clarify anything that you feel you need to, or to move brighter stars out of the field so it allows you to see fainter stars or objects in the field. Lucian Kimball of Kimball's Cascade used to throw the view out of focus at this point to allow the bright stars to be seen more clearly, while the dimmer stars will disappear. And it makes the field a lot less intimidating. Once the outer bright stars are drawn, I will next indicate the brighter stars of the cluster, as in figure 3. The brighter the star, the larger the dot that you create to represent it, just as it is on your star charts. Using the outer stars as a guide, determine the position of the main stars relative to them and each other, and to get the right scale. It's easier to do than it might sound, but if you don't get it right at first, don't worry about it. You can use an eraser if you want to. I typically don't when I'm sketching at the eyepiece. If you are going to use an eraser, make sure it's a good one, because a lot of the vinyl erasers showing up these days all they do is smudge. And if that happens, it makes a worse mess than you were trying to correct.
You're using pencil?
Using pencil, just a mechanical pencil. The best eraser to actually use is what's called a kneaded eraser or a kneadable eraser. If you're not familiar with erasers, it's an artist's eraser, and you can get them at Wallach's, Desserts. Any office supply store will have them. Don't buy the one made in China. It does not work. Normally what I would do is I would put an X through a star that I've misplaced. One of the reasons for that is that when you erase something, it's very difficult not to go back and put the dot back in exactly the same spot. It happens all the time. If you leave it there, you know where not to put it. Okay? You can then correct it later in the light. And I've actually got one star in here coming up in the next image that you'll see where I've crossed it out. It's up there. Oh, okay. Okay, so that one you'll see I'll deal with it later. Okay, so from here it's just a matter of placing the remaining stars. I usually look for patterns of stars that are easy to identify. Triangles, rectangles, arcs, V's, lines, whatever. The more stars or star groups that you place the easier it becomes to accurately place fainter and fainter stars. Just take your time, relax. Look at things. Is there something you've overlooked? Is there something out of place? Okay, now is the time to spend a couple minutes comparing your sketch to the eyepiece back and forth. You're never going to have exactly the same view again. Is there anything there that you see with averted vision? Put it in. Mark north and then either east or west so that you can orient yourself, and you're done. Figure 4, please. All right. I've pulled out the X'd star in that one, but I'll show you a little later. Okay, so now let's try something a little more complicated. M27, the Dumbbell Nebula, and for reference I've pulled this off of Stellarium, set at about the same view as the 13 mil Hyperion. And again, we start with the periphery stars to establish the border. Okay, you want to place the brighter stars to define the space and provide the references. Once these are drawn, you can start on the nebula itself. Here, this is where I switch to usually a different pencil. I use one that has quite a dull point to it so that I can put strokes that aren't going to leave hard lines, and they blend a lot easier. It's generally working with the side of the pencil. If you haven't tried it, just play for a couple minutes and just get the feel of it, because you don't want to leave hard lines. You can use something like a Q-tip, a rolled up piece of Kleenex or something, or your finger to smudge and blend things. If you use your finger, remember it's dirty. Don't create half a dozen other nebula in your sketch. Okay. Check the nebula. Again, you're just looking in detail. Are there other bright areas? Are there any other things that you need to define? Lighter areas, darker areas, and just adjust them. If there are any fainter field stars, put them in. Okay, that's figure 7. Okay, again, you're going to review the drawing and compare it very carefully to what you're seeing in the eyepiece. Don't be afraid to use higher magnification to see more detail. Are you picking up any color? Make notes of it in your log, because you can then add it in later. If you're satisfied with what you captured in the eyepiece, then you're done. Label the drawing and the object, name and designation, time, eyepiece details, and so on. Figure 8. If I'm presenting sketches, I usually need to clean them up because my stars aren't always circular. Sometimes they look like a lot of comets. I use Corel Paint Shop Pro, but any similar software would work. So I use the airbrush tool, a little round spray, and I can adjust it to whatever size to correct any misshaped stars or sizes. Okay, and in the M103 sketch, you'll see I've inverted it and I've eliminated the other star that was there. That's okay. So this is going to give you white stars on a black background. At this point, you can go back in with the airbrush tool, and you can add color to any of the stars that you want. You can also use some of the smudging tools to blend the nebula, as in the next figure.
Gordon, do you record the colors as you're sketching them?
Yes. Okay. I've tried to do color sketching at the eyepiece, but if you're working under a red light, your colors are way off. I've done some sketching with colored stars where I've tried to standardize on a series of colors and work that way. I find it's easier just to actually make a note right on the sketch, and then I'll make a color note on the sketch, and then I'll add it afterwards, and I can paint out the note. On this sketch, you'll notice doesn't show a whole lot. I've added just a hint of green to the nebula. Okay, so next one's a lunar sketch. They're a little more challenging because there's a lot more information there. And you've got to make a lot of decisions about a lunar sketch. There's absolutely nothing wrong with just doing an outline of the craters for the placement and the sizes. That's fine, if that's what you want. You can take that as far as you want. I've gone quite far. I actually spent about an hour doing the one that we're gonna end up with here. And it's actually a little more finished than the ones I typically do at the eyepiece. Okay, so basically there are two ways to proceed. No, you go down with mommy. Okay, you can create your sketches on white paper, where the bright highlights of the lunar surface are represented by the white of the paper, and you work with a dark medium to create the surrounding areas and the shadows. Or you can work with a dark black paper and use a white pencil or charcoal or pastel. Both have their advantages. I have done both. I'm going to be preparing something on working with the dark or with the white medium on dark papers, but for now I'm just concentrating on working with graphite. I find it's easier because I like to have these sketches as part of my logbook, and when I work the other way, I'm not working in my logbook. So, okay, so for this, I'm working from a photo I took of the Ptolemais Alphonsus or Ezekiel area. Okay, again, here I tend to work with not with a mechanical pencil, but usually with a softer, rounder pencil. And for the same reasons as with the nebula. As I get closer to finishing the drawing, I'll switch to the sharper pencils to sharpen up edges. If I'm working with the Terminator, which we are here, then I usually start by defining the dark areas first, the dark Terminator edge at that side. But before you start a lunar sketch, you've got to decide what all you're going to include in the sketch, because there's a lot there. Center one's is the center one? Okay, that's fine. So I'm just going to concentrate on the three main craters and just put in enough detail on the other side to define the area. But you've got to work that out ahead of time, because otherwise you'll stay there till the moon disappears below the horizon trying to get in every last detail, and you're working further and further from the Terminator. Okay, so I start by defining the dark edge of the Terminator, as this is what defines the brightly lit edges of the crater. Next, I define the shadow side of the craters. Next figure, please. Okay, so look closely as you scan these shadows, as these will define the center one's the pointer. Yep. Okay, so those are going to define the shape of the mountain. That's the shadow of the mountain. Okay, so you've got to watch those shapes closely. Okay, from here it's just a matter of working out from that shadowed edge to define the surrounding areas. And this is probably the most demanding part of the whole process, because it takes the most attention, the most intense seeing.
Gordon, you're tracking the moon as you're drawing it, right?
I've done it with both. I've done it with where I have to keep nudging the telescope to keep up with it, and I also have a motorized scope that I use. Motorized is much easier because you're not breaking your concentration. Yeah, it's much easier. But typically with the lunar sketches, I try to get them done in about 10 minutes, maybe 15. So you don't have to nudge it a whole lot. Okay. So you'll find that there are a great many gray tones on the lunar surface that are define the different amount of lights that different areas are getting. And seeing those subtle differences and placing them in your sketch just requires patience and careful observing. There's an exercise that I use when I'm teaching drawing that's worth discussing. I have students create a grayscale ranging from paper white to the blackest black that they can make. And in the drawing classes, I push them to make 8 other tones between that black and the white. Okay, so, but for the purposes here, you only really need 4 in between that. That's going to, and in most artistic endeavors, you really only need about 6 separate tones. Okay, so this is going to give you a range to deal with the ranges that you see on the lunar surface. It's not a bad idea to take 5 minutes and practice this a couple of times. Doesn't have to be big. You can do the whole thing in about, a 3-inch rectangle, divide it up into 6 squares. They're maybe, half an inch tall, and just create varying tones. Okay, and it should be able to go from white to a black. And if you squint at it, it should look curved because you're recreating how light follows a curve. Lost my place. Okay, so a little practice with that is going to really, really pay off well when you're sketching, because you won't have to think about how to create those tones, how to create those differences. You'll be used to seeing them and creating them. The single reason that most sketches, and indeed most artistic endeavors by amateurs, fail is because they don't recreate an accurate representation of the contrast and of those values. It's the single biggest reason. If you go to any local art show by a local watercolor group and you look at it, if you stand back and squint at it, you see one tone. Okay? And when you open your eyes fully, there's a sky and a ground that's supposedly lit, trees with shadows, and it's all the same value. You need to create the contrast, because it's the darks that will tell you how bright your lights are. Okay, so work out as far as you need to define the crater shapes that you're interested in. Take your time. Observe carefully. You will want to include some of the nearby craters and ridges and other details just to define the lay of the land, but you don't have to go too far. Next, please. From here, you need to adjust the values, refine the details, sharpen the edges, add any final observations. Spend a few minutes going back and forth from the eyepiece to your sketch, checking to see that you haven't overlooked something completely. Be sure that you're happy with the level of detail, because you could quit at this point and you've got a rough representation of what that area looks like. If you want to go into more detail, you can. Okay, next please. When you're satisfied that you've got all the information you want and you're satisfied with the representation, label it, date it, time, telescope, and information. At this point, I usually have to leave what it was that I've drawn blank, because I don't know. And I'll have to go check the lunar atlas to find out what crater it was I was looking at. That's basically the process. The tools involved here, all of these sketches were done with a regular HB pencil and an HB lead and a mechanical pencil. For the early stages of the lunar sketch, I used a carpenter's pencil to block in the darks, just because it's faster, it's a bigger edge. The only other thing you need is an eraser. As I mentioned before, I like the kneadable eraser. That is this one over here, and it's just gummy. It's very soft, and you break off pieces of it and you knead it to warm it up and make it very soft and pliable. It lifts virtually anything, and they last forever. Okay, I also use the vinyl eraser on the end of a mechanical pencil. So these are the least expensive astronomical accessories you're ever going to buy. They will allow you to see deeper and in more detail than the most expensive eyepiece that you can buy. You don't need anything more than what's shown here to sketch anything in the universe that catches your imagination. I hope you'll give it a try, and I look forward to seeing what you saw. Thank you. Any questions or anything? And if anybody wants to see the original sketches, I do have them with me.
Yeah, 2 questions. What's
Yep.
your favorite telescope to sketch with? And the second is that a scan of a drawing that you showed us before?
Those are scans, yes.
Because it doesn't look like there's any paper texture on it at all.
Yeah. No, it's just a straight scan.
Okay.
Yeah.
What's your favorite telescope?
It doesn't matter.
Refractor, reflector?
Depends on what I'm looking at. It really doesn't matter. Motorized, much preferred over non-motorized. It just takes that whole element of keeping everything in the same relative position. But I've got a 127 Mac that I really like to use for the lunar sketches. And obviously for the deep sky stuff, the 12-inch is marvelous. But some of my better sketches of deep sky stuff have been with a 120 refractor. So it really, the telescope's not really important. It's what you're seeing in the eyepiece and how much attention to detail you're paying. That's really what it's down to.
Gordon, I
Yes.
have a question.
Yes.
I've been sketching the sun for the last 20 years. Sunspots?
Yes?
You didn't mention this, but I found you only need two things for the sun. You need a very fine pen. You know, one of those fine
Yes.
pens that draw very finely to do the umbra. If you want to do the penumbra, you just use a pencil, but you would use a hard pencil because the penumbra is not that dark.
You have more faith
So
in your...
those two things are sufficient. As I said, I've done this for 20 years now.
Yeah, you're absolutely right. I mean, the contrast is the key thing, getting the darks dark enough. You have more confidence in your drawing ability than I do. I'm afraid to touch a pen when I'm drawing because it doesn't erase.
No, well, if I
But-
make a mistake, I redo it.
Yeah, yeah.
It's only a small little piece of paper, so I throw the one away that's wrong and make another one.
Yeah, but the key thing is there is getting the dark as you need it,
Oh,
right?
Yeah. It's a black pen, not a blue, but a black pen.
Yep.
And the pencil, as I said, is one of those H1 or something.
Yes.
Because it's a little lighter, but it's not dark. The penumbra is not that dark, you see.
Yeah, yeah. No, if you're comfortable using a pen, by all means, and there are certain things where to get the contrast, you're going to need that. Yeah.
Actually, what you should do, but I don't, a lad once told me about this. You should have two pens. You should have one, and don't hold a pen like you do. Hold it perpendicular
Vertically,
to the
yes.
paper.
Yep,
And you make a dot by twisting the pen.
yes.
And if you want a bigger dot, you use another pen.
Use a larger pen.
And so you make your dots accordingly, but you don't use it sideways or draw a circle. You twist the circle.
Exactly, yeah. Because the dot, you never know quite how it's going to, what mark it's going to reproduce, and by doing
Point
it,
it
yeah,
like that, perpendicular to the paper, twist it, there you got your...
yeah. And you'll have a sharp circle, or a sharp dot as opposed to something with a little tail on it. Yeah, yeah. Any other questions?
Yeah, go with it.
Sorry, I can't see. Oh, yes.
What's the nature of the lighting you're using while you're sketching?
Typically, I use a flashlight where I've just painted the face of it red. And so it's just a dim red light. On lunar sketches, I had a flashlight that had a much brighter red filter on it. And I would use that, because with the lunar sketches, you don't have to preserve your night vision quite the way you do with deep sky things. And it's much easier to see what you're doing accurately if you're using a brighter light. But just normally just a flashlight.
Do you sketch flat on a table, or do you sketch on an easel? Like
No, most of the time it's it's flat on a table. I have my sketch pad. I have my logbook here with me. Okay. Whoop, sorry. And I'll just lay it. I have a little table that I set up beside my telescope, and that's what I draw on, just flat. The reason for using an easel is that to prevent perspective distortion. Okay. But if you've got an easel that you can set up that works nicely, yeah, that would be fine. And actually, that's a good idea, because I have a problem with my 12-inch. My table's too low, and if I'm sitting up high, I end up doing it in my lap, and it's awkward. Yes, at the back.
So are you scanning in those pencil drawings to the computer and then using a drawing program to massage them?
Yeah, I scan them in, and then I'm using Corel, what is it, Corel Paint Shop? Yeah, Corel Paint Shop Pro. And I'll just go in and clean them up in that.
Gordon, do you find there's a problem when you're doing your sketches? You know how paper gets damp very quickly in the fall and in the spring? Do you find that that's a problem?
That's why I use this folder.
Yeah.
It's only open when I'm working at the paper,
Yeah.
and so it keeps it dry. Yeah, I have noticed if I leave it open, it
Yeah.
gets quite damp
Some
some
nights,
nights,
yeah.
Gets some nights I find there are people skating on it. So, it's, any others?
I want to see Julia's drawings.
Well, she did one on her first presentation. She did her little sketch of the Big Dipper.
That's right.
I want to know why Paul hasn't submitted his sketches of the sewer.
I wasn't going to ask.
There you go, Paul, there's an opening for you.
Okay.
Thank you very much.
Thanks, Gordon.
That's great. Thank you, Gordon. Now we know how you do those lovely images that get published. All right. Well, sorry, what was that? Oh. All right, next up is Chuck giving us an update on the meteor craters, the White Court. And I'm just sort of waiting to see whether I've got a crater named after me or not. He promised me an update there. All right, Chuck.
Full update. Yeah, that was a good segue from lunar craters to craters on this planet. Okay, where are we here? Oh, here we are. So, the last, when Jillian and I did our presentation in November, there was a few questions, and I couldn't answer them, so I researched the data. And essentially what we have is the White Court crater, just a quick review. Edmonton, where are we here? Edmonton, just to the northwest of Edmonton in Alberta. And the crater is just around in this area here. You can see it there somewhere? Those are the tracks from my locator on the airplane. But the crater is in there somewhere. And this is a LiDAR image of the crater. This is sort of like an aerial image. The crater's right there, actually. And the LiDAR is a way of eliminating the noise from the vegetation so you can actually see the ground. And this was a good beta test of the system, and they're basically it's been proven that fact that we can see ground effects. Now the first question we had was actually from Paul, and he noticed a couple of pseudo-craters here. And we had great expectations of the new Paul Cloninger crater in Alberta. But I asked Dr. Hurd, and this is his quote. What were the two craters in the upper right of the image? Well, he says both of these potential craters were checked. The one closest to the actual crater is the remains of an old homestead, and the other one to the far northeast is also man-made from homesteading or forestry. So years and years ago, somebody was actually here trying to farm this. I'm not sure, they weren't very successful because the land wasn't very fertile. But another point in this LiDAR image is this creek here. And Dr. Hurd described it as ephemeral. Ephemeral? Is that how you pronounce it? Basically, it was a creek that was there before the crater, and it hasn't had too much water in it since. Which brings me to the second question that Simon asked. When I described the ejecta from the crater, you see all these sample points here is where the students were digging, and Simon asked, well, why is there ejecta in the creek? You think after 1,000 years it would have been eroded away. Well, again, his answer is, quote, the ejecta does not appear to have been significantly eroded since the impact, although there is a little of interpretation there. I don't know how many auger holes my student did in the actual steam bed, but not many. However, it is an ephemeral transitory stream with water in it only in the wettest years in the spring. So suffice to say that there has been very little, if any, erosion of the ejecta since the impact. So that's the answer, Simon. And the third question, Brian, asked me what the exact meteorite was. And just a quick review. It's kind of fascinating, actually. The meteorite that were found around the crater are actually two types. One with the regoliths, the erosion that happens with the transit through the atmosphere, and this shrapnel. And they were both identical meteorites, iron, and the exact type is a type 3AB iron meteoroid, which is low nickel metal areas, and it's actually right from the core of an asteroid. But the point here is that this shrapnel was actually blasted away from the bolide on impact. Part of it vaporized, part of it actually exploded, which you get this shrapnel. And then these parts here probably fell off on its transit through the atmosphere. So it's a very fascinating scientific hole in the ground that Dr. Hurd was researching. So that answered those questions, finally. Thank you. Now, this is a trip Jillian and I did last summer, actually on the way out to Whitecourt. We explored the northern Saskatchewan craters. And you can see Saskatchewan actually has been peppered by impacts over the years. Just a quick geology lesson. The pink area here is basically bedrock, and you'll see the types of craters in the bedrock. This is basically the deposits that created the prairies, basically the flat. Interior plains is the geological term, and it's been basically post the major extinction of 250 million years ago is when it was deposited, this part. This here is a big hunk of sand called the Athabasca Formation, marine sediments which are believed to be Middle Devonian of age. And we're going to see some fascinating pictures of that in a second. So, first crater we'll talk about, I'm going to go by age, is Elbow, 395 million years old. 8 kilometers across, Devonian age, strata distributed, and it's basically before the Great Extinction this happened. So the extinction I'm talking about is around 250 million years ago, the Permian Triassic, where about 99% of the life on this planet was extinguished. So that crater sort of got things started in Saskatchewan. That's where it was in the planet at that time. And there it is. You see it? This actually is Lake Diefenbaker. And the dam you see there is the Gardiner Dam. It's the largest embankment dam in Canada. Kind of cool to see. But a closer look at the crater, and there it is, Lake Diefenbaker in the background. So essentially you can't see anything, but I just had to fly over it to say, yeah, I've seen Elbow Crater. It's 8 kilometers in diameter. It's buried. And to my knowledge, there isn't any carbon or oil or anything underneath the crater for some reason. It's the oldest one, so probably whatever was in there is long, long gone. So, to the next one is the Gow Lake crater, and that happened just after that major extinction. It is just after the, about 250 million years ago. It's 5 kilometers across. And the dinosaurs at this time were just evolving. They were evolving from this little lizard called an Archosaurus. And the mammals had just started their evolution trail as well. So the two species were in competition throughout the Mesozoic here, which is a cool story. So that's what the world looked like when Gow hit. And it is actually a fascinating little structure. It is the smallest known complex impact structure. It's complex in that it has a central peak. There are simple craters bigger than this on this planet. We can't, nobody's explained to me yet why this is a complex crater where others were not formed as complex. Just as a trivia, the fog in the background is smoke from the forest fires in British Columbia as we're heading west. We came through a lot of smoke in our trip. It was kind of cool. Well, not cool, kind of warm.
Chuck, do you know if that island in the middle is part of the uplift, or was that after the crater?
This is the central peak of the crater itself. And it is, the impact melt is, basically the whole structure here is impact melt. This is a view from the east looking west towards British Columbia, and this is the view west looking east. And right on that point, there's this little lodge. It's kind of a neat little lodge. I'd like to research what's in there, because, Eric, that canoe trip across to the Central Peak would be kind of neat, wouldn't it?
Yeah, I was thinking about that.
Yeah, I was too. Have canoed, we'll travel. Yes, where are we here? Yeah, the cottage. It's the highest point. It's basically, it's all impact melt. So we could get a canoe full of rocks out of that one. So, age-wise, the next crater is the Viewfield crater in the south. Now, this is buried under the soil of the prairies itself. It's a big one, 39 kilometers across, 115 million years ago. So at this point, the dinosaurs have about 50 million years before they meet their Waterloo. So it's coming close. So you think with all these impacts happening, they think, let's start a space program, see what we can do. But they're just out killing mammals. That's all they were doing. Where are we here? We're on Viewfield. Yeah, 2.5 kilometers across, not very big. And our continental drift is getting a little bit more recognizable, North America. And there it is. Now this one here has a lot of oil rigs in it. That was kind of cool to watch. Basically it's wall-to-wall oil rigs around here in southern Manitoba. And point zero of the impact is right there. Can't see the crater, it's buried, but there it is. Yeah, it's a trap for hydrocarbons, and essentially it's they've been pumping oil for a long time, and there still are. So the next one, age-wise, is the Carswell, way up by Lake Athabasca. 39 kilometers across, and it could be bigger. There are lots of studies going on, a lot of contradicting evidence saying it's bigger, it's smaller. 115 million years ago, the dinosaurs have about 50 million years left before the big day. And as you say, the continent's getting a little bit more recognizable, and that's where the impact happened. The Athabasca Basin itself, sandy deposits from the Devonian. Now the interior, if you look at, the crater itself right there, the interior geologically is pink as granite. It's pure granite. The yellow ring is the disturbed Athabasca Formation, and the outer ring is dolomite. It's a sedimentary carbonate rock. So that's the form of it. It's kind of very recognizable in all the forms. Now this is the whole Athabasca Basin. And looking at this image, this is the crater itself. All this is sand. It is really neat to see. And inside the crater is basically it's all like this. And this is the crater rim from the ground. So it is. They say it's a ring of small hills about 50 meters high, and the diameter is about 30 kilometers to 40 kilometers. The hills. I really couldn't see it from the air. Ground zero is about here, and they say the ring of hills was around here somewhere, but from the air we couldn't really see it. And the smoke from the forest fires was just clearing a bit. So we did get a fairly good picture, but not as crystal clear as I wanted.
It's a bit smaller than Manicouagan.
Yes. The central island of Manicouagan going to be about this size. And then the trench where Eric and I almost met our Waterloo was a little bit bigger than that, but that was a story, wasn't it? So, and this is the sand dunes just south of Lake Athabasca. To see what I showed you, the Carswell, the formation, Lake Athabasca there in the sand dunes, all that is pretty well all sand. And of course the tar sands is part of it. Fascinating geology. So, next crater, where are we here? Is Deep Bay. Deep Bay, it's about 9.5 kilometers across. And the dinosaurs have about 34 million years. The clock is clicking. Where Deep Bay is, right about there, though, the inner ocean and the Iapetus is splitting apart for the Atlantic Ocean. So North America is pretty discernible at this point, but we're still getting peppered by impacts. The crater itself, it's kind of a unique one. It's 220 meters deep, the deepest in Manitoba, and essentially all the lakes around are no deeper than 50 meters. So from 50, that's why I call it obviously Deep Bay, 220 meters deep. The First Nations had a superstition about it. They wouldn't fish in there because it was so deep they didn't know what the heck they were going to catch. Yeah, or big fish.
Is the water clear like in some of the other craters like Pinguela?
Yeah, actually when we went along the coast we could see it as clear as Pinguela. I couldn't say. We'd have to be actually right there. No, not even half as clear as Pinguela.
Not clear, but it's cleaner than the other lakes.
Yes, oh yeah. We could see we could see rocks along the coast as we went here. And there actually is an outer ring of impact geology that you can see as we flew by it. And I just want to make a note. We're east looking west. We're heading for Fort McMurray way over there. But at this time of this picture, Saskatchewan, if you remember, had some major storms, major thunderstorms and tornadoes. And that there is a storm cloud of those tornadoes. It was severe clear up here where we were to the north, but Saskatchewan was really getting hit. And looking from the west, looking east, you can see there's Ontario, crystal clear skies all the way back. So yeah, we had a lucky trip there that way. So let's see, where are we here? Storm, yep. And the final one, where are we here? Maple Creek. Now Maple Creek is a small one, 6 kilometers across, 75 million years ago, almost at the point where the dinosaurs met their extinction. Yeah, you would think they'd realize that after 6 impacts, we better do something, but they didn't. That's pretty well where it was, and not much to see, but that's the relative size of the crater itself, 0.0 right there. Essentially, nothing's happening there at all. Nothing, absolutely. So there we go. So you see a comet? Well, let's hope it misses us. That's all I can say. I just want to make a plug here. I'm the keeper of the web now, and I know a lot of you have images, and what I'd like to do is put the odd image up every week or every month, depending how many images I get. So if anybody wants to have their image posted on the front page of our website, please email me. You don't have to send the image to me, just give me a URL where it is. I'll download it myself and then put it on. So there we go. Thank you very much.
Minutes, right?
You got it.
17.
17? So no crater, right? No crater for now? Don't know till you try, right? Thank you very much. That's good. I'm glad we got the update. Now I can rest at night. Now we have Pierre and Ramon who are going to talk to us about their Geminids adventure. And
okay, thank you, Paul.
You're welcome.
So yeah, so some of you will recall that Raymond and I took, we did an adventure a couple years ago to the Deer Lake Astronomy Village down in Georgia. We really enjoyed it so much, in fact, that for last year, for the December Geminids 2012, we felt, hey, let's do it again. Let's go down south where we'll get not as cold weather under clear skies, and a place where we can set up all our equipment, our cameras, and be more comfortable. So that was we decided to go on basically a road trip. So the plan was we really wanted to go back to Georgia, to the Deer Lake Astronomy Village, and along the way, a good part of the trip heading down. That was part of the plan, we got to Washington. We wanted to do a few things there, visit a little bit around the city, And at that point, we took a much more serious look at the weather forecast. And for us, it was a priority to have at least 2 clear nights, the 2 main nights of the Geminids, which was the night of the 12th and the 13th, which was going to be fairly equal as far as activity, since the peak was predicted to be very early in the evening of the 13th. And it's a fairly broad maximum, too, for this meteor shower. So once in Washington, we made the decision, do we keep going down south or do we go to our backup site, which was in southern Ohio? Well, the weather forecasts were not quite as favorable by then for the southern U.S. It looked like the state of Georgia would have probably just 1 out of the 2 nights clear. So we decided that, hey, let's go west. Let's go to the backup site in Ohio, which is called the Cincinnati Astronomical Society Dark Sky Site. And we made contact with the members there, and they were kind enough to get back to us very quickly and let us know what we needed to know to get there and to get into the site and have access to some of the facilities there. So that was our plan, and I have to say what really helped in my search for potential dark sky sites was Attila's Clear Sky Chart website. There's a huge directory of observing sites throughout Canada and the U.S., and it was really helpful to find this location. That's how I managed to stumble onto it and then get in touch with the Cincinnati club to make arrangements. So that really worked out. So there it is. We got to the site after visiting Washington. We got to the CDS site the next day. And getting into the site was actually a little bit scary. There's a really steep entrance that goes up. It's actually, the site is built on top of a good-sized hill. Once up onto the hill, it's actually nice and flat, as you can see. This, what you see here is a nice panorama that was assembled by Raymond.
This is their clubhouse, heated clubhouse. Here is where we installed ourselves. They had made themselves as a cement platform. Here are posts, electrical outlets. And for us at the far end, well, we put up our tents to camp there. It was a really nice site, really up. It looked really good, really liked the location.
Okay, thanks, Raymond. So and the skies were very dark. It was well set up. It's a MAG 6.5 dark skies. And the weather forecasts were just gorgeous. For the 2 days, we were sure that we were going to get the clear skies because it was right in the middle of that high pressure located deep under the Great Lakes. And the sky transparency was excellent for the 2 nights. With the exception of the second night, there was a little bit of cirrus clouds. It started off the evening. But it turned out that after an hour or two, right after sunset, close to or shortly after 9 o'clock in the evening, it was absolutely crystal clear, and I found it was actually turned out to be the best night, which was the actual peak of the Geminids. So quite spacious. The one downside was that it was actually quite muddy. It was the soil was very soft. What happened? It would freeze at night, so it would actually be nice and firm at night, but during the day, it was just warm enough to actually get quite soft. So we were glad to have our good boots with us. But yeah, very comfortable site. And just move across. We can see they're well equipped with AC outlets. The concrete pad here was very useful. We could set up all our stuff there and not have to worry about getting things having dirt on our equipment or cameras. And this little thing, this shelter right here, actually houses, I believe it's a 28-inch Dobsonian. So there's a few snapshots during the daytime, all our equipment. This is Ramon's cameras all ready for action, and my equatorial mount with my 2 DSLRs. And now, just briefly, the result for the Geminids turned out to be an excellent return for the Geminids, as is usually the case. It's a very reliable shower. To me, it's still the best meteor shower of the year. And this was well represented with the reports that were sent to the International Meteor Organization. So the Geminids reached a peak That was fairly broad at about 115 meters per hour with, this is assuming, that's a ZHR, so that's with very dark skies, assuming the radiant would be at the zenith. So it's basically they have formulas to compensate to produce this analysis based on the observations that were submitted. And the Geminids, as you can see, they have what's called an asymmetric profile. And what that means is the Geminids typically ramp up more slowly towards the peak than they do after the peak, which is actually a fairly sharp decline very soon after the maximum activity. And what's also interesting about the Geminids is during the climb to maximum activity, they typically produce a greater number of dimmer meteors than the bright ones. There's a few bright meteors thrown in, but typically on the average, they are fainter going up to the peak. And during the peak, they start to produce a number of fireballs. And then right after into the beginning of the sharp decline, there's a period that's known as the fireball time, which is a few hours where as the rates start to decline quickly, the dim meteors are far less numerous, and there's actually a lot of really bright fireballs. And we were fortunate, Raymond and I, to witness this. We saw, during the first night, we saw the activity rise up. Personally, on the late at night, on the morning, or I should say the morning of the 13th, I managed to get up to about 70 meters an hour, the best hour. And the second night, it started off fairly normal, but then around, as a radiant climb and close to 1 o'clock in the morning, it felt like things just went nuts. There was moments where we'd see 4 or 5 Geminids shooting across different directions within a minute. And beginning at 1 o'clock in the morning onwards, this is when we saw a good number of fireballs. And the best that I saw was a magnitude -7. There was a -6, a few -5s. Like it was really something else. And one of the more interesting ones was like a green ball that glided down into the sky and actually split in 2 pieces, very distinctly. So it was a really good shower, and typical actually for the Geminids, but it was a really good year, being coinciding right onto the new moon. It couldn't be a better year for the observing conditions. So now I'm going to let Raymond talk about his results, and also talk about a special guest that we had for the second night.
These are photos that I haven't even worked on. Those are raw from the camera. Just I did straight JPEG on. Okay. And I'm just going to show you the photos I got as during the nights, so you can see what we're getting on the shots. I couldn't even believe it that I got 2 at the same time with 1 photo. Only when I was doing the review that I noticed that together. Neat, eh?
How long were your individual shots around?
Some of them were 20 seconds at the beginning of the evening, and at the end, during the night, I was doing about 60 seconds exposure at about f4.
And ISO?
ISO, that one I was doing around 1200, 1250.
Raymond, is that a single image?
Yeah, that is a single, those are single images.
That bright one is a sporadic.
Yeah, that one's a sporadic, eh? Pretty cool, eh? Yeah. Now you can see on the top left, a plane passing by. We all know the telltale sign. Now, here's a special guest. Okay? He took the photo of me and myself. It's John Schumack from Ohio. He's an astrophotographer in Dayton, Ohio. And I contacted him after I met him 13 years ago in Europe for a solar eclipse in 1999 in Europe. We haven't seen each other for 13 years. I was near his neighborhood. I called him up. Do you want to come down and visit us and see our site? He said, sure. So here we are together with his photo of the evening sky with some meteors going. This is his shot of the Milky Way, of where we were. Pretty good, eh? And
Pierre's third. Okay. Thank you, Raymond. So as I mentioned, the second night especially was spectacular, like the transparency, the sky conditions, and all. I had my two cameras running. They were automated with a timer controller so that I could really focus on most of my time observing in my cocoon. I had my big -40 sleeping bag, even though the temperature never went down more than -4. It was a bit overkill, but I didn't want to take the risk where we were going to, not knowing where we're going to be end up for observing. So the shower was really active. My best hour on the second night produced over 100 meteors. That was the period right after 1 o'clock in the morning. That 1 hour was the most active. And what's interesting is we're seeing the fireballs and a lot of the bright stuff. And then the last hour, at the very end of the night, it's almost like the Geminids had nearly switched off. The decline was now so pronounced that they were still active, but my last hour was down to only about 30 or so Geminids. So I always tell people when someone asks me when's the best time to observe the Geminids, and if the peak is clouded over, I tell them, well, make sure you watch them before the peak, and when you see that more gradual upswing, because after the peak, they usually drop like a rock, and that's pretty typical. So I did a number of composite shots. The first ones are the first night we were out, which started being active. So on this one, you can see a few meteors. This one here is a composite with my full frame camera, a Canon 5D with a 15 millimeter fisheye lens. So this produced actually a huge field of view. There's Polaris right here, Ursa Minor. Ursa Major is right over here, I believe, M45. So the interesting thing was to see the sky, the difference in the sky. We were just far south enough at 30 degrees latitude to see the constellations in a sort of unusual way. Orion would rise on a different angle and set in a different angle. And it's actually Raymond who mentioned that during the night, and he noticed everything is sort of different, and the Big Dipper is coming up this way, and it does show quite a bit. So this one has 26 Geminids. The average brightness meteors, a few bright ones. This one was, I think, a -2 or so. Now, this composite, this was with my second camera, the Canon 7D, with a 17 mil lens at f2.8. So this is a composite of multiple exposures, of course, like the previous two shots. And what I did for the meteors, I went with very short exposures, 20-second or so exposures. Very fast setting. I had the lens set up at f2.8, and the ISO cranked all the way to ISO 1600, just to try to get a maximum sensitivity, because the meteors, even though the Geminids are fairly moderate speed meteors, they still move fairly fast into the camera's sensor. Then for my star field shot, this is where I use a longer exposure with the lens aperture stopped down to f4.5, and the ISO also reduced to ISO 800, just to get a much cleaner shot and more pinpoint stars across the field of view, and also to reduce vignetting. So this one has 33 Geminids. Now moving on to the second night, this was at the very beginning of the evening. I set up my camera along with the tree line in the northeast, and captured a few. This one was a particularly long Geminid. And this was a time where, or shortly after the time where we actually saw a few nice Earth grazers when the radiant is still very low on the horizon. And the shower is active enough to produce a few meteors that are streaming long distance across the sky. So we saw a few of those visually. And there's the composite taken on the second night. As you can see, meteors were way brighter. There was a lot more going on, even though we were just past the actual time of maximum activity. This one was taken with the full frame camera, but with a 50 millimeter lens. So you have Orion here, sort of tilted a little bit, and the bright planet Jupiter, along with Aldebaran. And this one here was one of the big fireballs that went up to about -5, I believe. So 53 Geminids captured with that field of view, which was basically running several hours, the full 8 or so hours. And then the last composite, this one took me several hours to assemble because there is quite a process. I haven't figured out a more effective way of stacking my images because I find doing it the automated way, it seems to dim the meteors too much. So I bring everything into Photoshop, all into separate layers. And then I basically mask the sky. I position each frame correctly on my star field image, and then basically subtract the sky around each and every meteor that you see. So it was a process I had to do 98 times for the amount of meteors that I have on this shot. So this was taken with the 7D, a 1.6 crop camera at 17 millimeter. And again, this is the same fireball that was captured on the other camera. But you can see a lot of very short meteors. There's one right here, and there's actually, this looks almost like a star, but this is actually a meteor that's just next to the radiant. And it's highly foreshortened, and otherwise it's basically coming head-on towards the camera. So lastly, this is one of the fireballs. I made an animated GIF here to show the train, the persistent train that was left over. So what you're seeing is basically 8 minutes compressed down into a few seconds. So that was I think a mag -4 Geminid that left a train, which was a little bit unusual because the Geminids, they don't move at a very high velocity. So as opposed to the Perseids or the Leonids, not very many Geminids typically leave trains. So this year, somehow, I was seeing a little bit more. And to the eye, I think I saw this train lasting for maybe about 5 seconds. But the camera, being much more sensitive, captured a lot more of it for a while.
Oh, and by the way, are you catching the satellites passing through the skies?
Yeah, there's several satellites. I believe...
The top right one has 2 side to side.
Yeah.
We have to talk to Kevin to find out what they're all about.
I'm not sure what they are, but I do suspect that they're geo satellites. And that's because my field of view is tracking the stars, and the satellites are moving along with I believe, the Earth's surface. They're just sort of going along the plane of the celestial equator. So I think they're part of a whole constellation of geo satellites that are like way out in Earth's orbit.
That's Orion's belt, isn't it?
Orion's belt, yes, right here. So the shot is actually inverted. M42 would be down here.
That's the plane there.
Yes, right here. Actually, you're right. And this is one of the meteors that that are highly cropped because I really wanted to see the train in detail. And one more. This was a 4-minute train that you see in a span of a couple seconds. Okay, thank you very much.
Awesome.
Thank you.
Any questions?
Oh, questions. Any questions?
Can't see you, so you have to try to. No?
Great work, Pierre.
Oh, thank you.
Absolutely.
Thank you very much.
Thank you. Thanks, gentlemen. All right. Well, thank you very much for sharing that with us. It's much appreciated. That's some beautiful work there from both of you. Very stunning. I love the animated GIFs there of the trail. Super stuff. All right, moving right along. Last but not least, we have Mr. Ledrew, who's going to talk to us about making star charts. All yours, Glenn. Do you want the lights dimmed at all, or are you okay?
No, this is fine.
You okay?
Yeah, starting back in about 1999, I began to write some very simple basic programs in Microsoft Quick Basic, working in DOS, to create little star charts to do some of my investigation on some of my early star cluster discoveries. And then it kind of evolved over time as I improved the techniques to better represent the stars, and then that kind of morphed into using them as illustrations for some articles that I began doing around 2000, I guess, for Sky News. And here's just a quick outline of the process. It's kind of laborious, time-consuming, and crude in the extreme. I really should try to upgrade my programming skills to Visual Basic so that I can generate larger, higher resolution individual frames, because as it is right now, I'm limited to the VGA standard, which is 640 by 480 pixels. Just for comparison, the screen you're looking at here is 1024 by 768. which is approaching double the resolution, or not a lot less, say, than 4 times the pixel density in the image. So in order to make something that looks decent, I've written the program so that I'm really producing individual tiles to reassemble later as a mosaic. So here's just a kind of an overview where I've taken 5 key subframes. Each individual one is only 640 by 480 pixels. And for a full-page illustration, to give it reasonable quality so it doesn't look highly pixelated, I do a 3 by 5 mosaic, which then results in a 1920 pixel wide by 2400 pixel tall image in total. So in all cases, the center of projection is in the middle, and I just designed the software so I just, one after the other, select which of the tiles, 1, 2, 3, and so on, right down to 15, and pump out these small bits, and then in Photoshop later put them together. And that's kind of what I've started doing here in this example. Now here are 4 close-ups. I'm actually oversampling here by zooming in to make things look twice as large as they are. It's not 1-to-1 pixel mapping, but instead a 2-to-1 zoom in, just so that you can actually see the rasterization or the pixelization of these individual images, so you can see what happens as I do the processing. Now for the stars, because I want to have control over the appearance over a large range of magnitude, I actually generate 4 separate layers to then build up to produce my final star layer. In the upper left, here is just the faintest 1/2 magnitude of the star field. Here, say, between magnitude 10.5 and magnitude 11. And then in the right, here is another separate layer where I am just producing small compact dots which will represent the brighter core of the star. And for the brighter stars, I just stop at a certain magnitude, let's say around 4th magnitude. In this case, any stars that are brighter, I just keep them all at the same size because they're going to be remaining as a kind of a bright white core for the star at the end. In the lower left is another layer which plots all the stars except for those faintest ones, but they're all scaled somewhat larger, and with the color, the blue minus visual color index that's scaled to give them between the bluish through the white and the yellowish, orange, and reddish stars. And then on the right is a separate layer for just those brightest stars from about 4th magnitude up, which are given a very large disk, which is going to be heavily blurred after to give a bigger blur to give the impression of a much brighter star. So here is just the same thing where I've now done the individual processing that's going to be performed. If I just flick back and forth here, you'll see in the upper left, I've reduced the opacity of the faint star layer, this guy here, because I just want those to be pushed a little more into the background to indicate the point where the stars are beginning to fade to invisibility. In the lower left, this frame here, all I do, is just give the stars a very slight blur of about 0.8 pixels radius, just to smooth them out. And then in the lower right, you can see very heavy blurring of between 4 and about 6 pixels radius, depending on the size of the circle that I'm blurring out. And that simulates the big brighter blob for the brightest stars. Here is at the same scale, but now I'm showing a screen filling view. Again, we're zoomed in 2-to-1, so you can still see the rasterizing and pixelization, but it now shows you what's happening with the stars when everything is put together. So the brightest stars, this being Orion's belt, they just have the fairly bright, intense-looking core with a larger fuzz to suggest brightness. In my early days, I would just naively apply the same sort of blur to even the bigger, brighter stars. They would just be a great big fat disk with a blur, and I found that was very ugly looking. It lost the impression of a star-like point. Then what I'll do is, if there are any nebulosities, I'll just add those in, and I have different ways of treating them. Sometimes for simpler ones, I just might plot them very crudely or even just draw them out and do a little bit of artistic tweaking. If I want to retain some semblance of detail, especially in the more complex nebulosities, like for instance the flame here, I'll just grab a photograph, methodically remove all the stars, scale the image to suit, and put it in as part of the layer for the nebulosities, and perhaps do a little bit of color adjustment or further blurring to feather out the edges and so on, just to give a sort of pseudo-photo visual kind of appearance. Then I'll add a sky glow, because the real night sky is not pitch black no matter where you are on Earth. There's always a glow. And another advantage is that in printing, when you're trying to represent fainter nebulosities, if you have a very black looking sky, there's always the risk of clipping occurring, and the fainter parts of the nebulosity will be artificially clipped, maybe even to the point of invisibility. So I have a twofold effect going here. I have enough of a sky background to ensure that we're maintaining the tonal gradations for the really faint parts of the nebulosities where they fade into the sky without getting an artificial sharp clipping, and it also shows a view that's a little more like what you see the sky as, especially with the naked eye or with instruments with a large exit pupil. The sky has a very considerable bright glow to it. And then another layer I will add is to indicate circles to locate the positions of objects or delineate their outlines and so on. And another layer, of course, for labels. If there are star clusters, I'll have a separate layer for it. And in the end, the total effect can have, at least a dozen individual layers with all these different elements treated separately, and that's how I submit it to Terry at Sky News, who passes it on to his graphic artists, because then they maintain full control to adjust things as necessary. Now we're zoomed out here so that it's a one-to-one sampling. So now you're seeing 1 pixel of the image mapped to 1 pixel on the screen. So you're seeing the maximum detail without losing anything with further zooming out, which would then further undersample. Of course, in this view, you can see now we're including the Orion Nebula and the Running Man Nebula, as well as Barnard's Loop. With further zooming out, now here's the full extent of the chart across the full width of 1920 pixels, which if this projector were capable of that resolution, it would look rather sharper. But right now we're undersampling, just limiting to that 1024 pixel wide screen. And here is now the entire chart sampling the full 2400 pixels vertically. Of course, in print, it would look better because the dot pitch is sufficient to represent the detail, meaning that you would see the fainter stars that here are probably starting to get dropped off, just being due to being undersampled a little too severely. The Milky Way, here I just did that very simply just by blocking in really a single tone and then just gave it a very heavy Gaussian blur just to blend out the edge. But in some of my other illustrations, especially of the summer sky where the Milky Way has an awful lot of intricate detail, I've created another version of the program that plots out isophotes of the Milky Way, which I actually created rather laboriously, again, back in about 99 or thereabouts, where I took Axel Mellinger's printed mosaic of the Milky Way as published by Sky and Telescope, placed it on a light table. I overlaid charts produced at the same scale and the same projection with David Chandler's Deep Space software that he produced back in the 90s, another little utility that ran in DOS. And I traced out up to 7 brightness levels, what I thought would be representative isophotes, and then I scanned those, overlaid them back into, I think it was software BISC's The Sky, and then retraced all this scan to create a digitized set of coordinates for all the different brightness levels, which I then read in my little simple program to plot them on screen, fill them in with the chosen color, and I have enough detail here to show things like the galactic Dark Horse Nebula complex. The star Antares would be about here, and this is one of the more prominent dark nebula complexes in the summer sky. And here is a zoomed out view that I had created for one of my articles covering the summertime supergiant stars. And this is the full extent as appeared in the illustration. And of course, just leaving it like this would be rather ugly because of the the hard stepping between the different isophotes. So then in the end, what I have to do is a lot of manual work, because I can't just apply a global Gaussian blur to that, or else you would lose all the fine, intricate structures if you want to blur it sufficiently to make the very broad outer parts also blur. So what I'll do is I'll manually, using a burn-in tool in Photoshop to dim down the edges on larger areas, I'll blend in with a blurring tool various edges using different sized blur tools, and work it at different scales over the whole works. And it takes hours of doing that. It would be nice to find a way to automate it. And then in the end, when built in with everything else, then I end up with something that I strive to give a reasonable representation that has a good continuous tonal variation that looks much like the way we see the Milky Way. So that's in a nutshell. Does anyone have any questions?
So Glenn, for a chart like that, how many hours would you estimate that it does take you?
It's probably about 2 working days.
Okay.
Something of that
15,
order.
16 hours type of thing? Or
Yeah, it could be something like that.
About, what, 3 hours or something?
No, probably something like 7-hour work days, so maybe 15 hours for that. The Milky Way, it certainly takes the longest chunk of time if I'm covering a detailed big area of the sky like that.
Question back here.
Yep.
I want to ask a question about the Gaussian blur that you were talking about.
Yep.
How do you apply the Gaussian blur to the image? I didn't quite understand that. Do you use some form of convolution?
Applying the blur to which element?
Yeah, you were talking about having a Gaussian blur, so I wasn't quite sure how you did that.
Do you mean to the stars, or? Oh, yeah, that's just built right into Photoshop. There's a Gaussian blur function, and then all I do is I select the radius of action to control how much I want to blend things out. So for just the stars, like the ones that were in the lower left-hand panels that I had shown earlier on, that's just a 0.8 pixel radius, just enough to take the hard edge off to suggest something a little bit more fuzzed without the stair-stepping rasterizing effect of the hard edge of the plotted symbols still coming through. And then for the other brighter stars where I plot a big blob of a dot, then I give it a much larger radius of blurring to spread it out into a bigger halo. So that's just built right into Photoshop. You can do just regular blurring. I use a Gaussian blur, and just seems to work best for the purpose.
How do you take into account atmospheric attenuation?
Oh, well, that's a good question, because for charts like this, actually, I built into the program the ability to put in atmospheric attenuation as well as the coloring of the stars with altitude in the sky. So what I'll do is, as we get down toward the horizon, the stars are dimmed with a mathematical algorithm that more or less matches the extinction, such that by the time you get right to the horizon, the stars are dimmed by about 3 magnitudes, which is a factor of about 16 times fainter. And as well, I apply an extra reddening to the B minus V color that I assign to the star. I'll give it a reddening, much like what happens with interstellar extinction. With a certain amount of extinction, there is a proportionate amount of reddening that goes hand in hand with that. So yeah, that's another thing that I can put in as an option, especially for the larger scale charts that include a nice swath of the horizon. Yes, I'll do that as well. And the data that I use for the stars, all I do, I've already got a shrunk down version of the Hipparcos catalog on my computer, and all I've retained for that, for speed of reading and plotting, is just the right ascension, declination, blue magnitude, and visual magnitude. The visual, of course, determines the basic visual brightness, and the blue, I just do a subtraction to get the B minus V color index, which determines the color of the star as it would appear to the eye. So I'm not basing color on the spectral type, but on the actual observed color index. Any other questions?
Do you invert your star charts?
Invert them? You mean to make it like a...
What's dark is light, vice versa?
I never have. Well, for some of my own investigations, I've done things like that, but not for publication. I'm just producing, images that are more or less representative of the way we see things. But it's easy to do an inversion. If I wanted to subtract the color, first of all, I can just take it out to turn it to grayscale and then invert it, and then you've got, black stars on a white background and such. That'd be the kind of thing that's child's play to do in Photoshop if you wanted to make a printout for, say, use at in the field or something like that.
So Glenn, to put the nebulae in, like the witch head and the flame, where did those images come from?
Well, sometimes what I'll do is grab something with Google Images, do a quick search if I deem it suitable, and then what I'll do is I'll just subtract out all the stars using the dust and scratches feature if the stars are small enough points, and then I'll do some further tweaking sometimes to further feather edges, maybe a color adjustment, but just things like that, and then I end up doctoring them up to the point to change their scale, skew and distort to fit if the projection is different that I'm using, and depending on where it would appear in the photograph. Sometimes there's even distortions like that, especially on large scale, like with Barnard's loop. In that case, it took a fair bit of tweaking of things to bend it to fit based on the position in the sky.
What constellations do you have in that particular picture?
Oh my! Well, this is
Does that cover the whole thing?
Well, it's probably a little more than half the full area of the sky. You've got Cassiopeia at the top, and of course right down to Scorpius down here near the southern horizon. And the center of the overhead point, the zenith, is right about here. That's another thing as well that I do is when I'm adding sky glow in wide-angle images like this, I will do it in a radial fashion so that it's brightest overhead, getting continually brighter toward the horizon, but also have an additional layer that has a bit of now darkening near the horizon because the atmosphere attenuates the light from the sky glow layer such that the air glow gets brighter toward the horizon, but then kind of inverts and starts getting darker because of extinction. So that's an extra wrinkle as well. So there's even two layers just for that. One for the sky glow, and then another one to put a darker band, a blurred darkening near the horizon. Yeah, so a lot of constellations in that view. I mean, the summer triangle, for instance, is right here, these three brightest stars. Well, I think that's about it. Thank you for your attention.
Well, thank you, Glenn. So next time you look at your star charts in Sky News, you'll realize the amount of work that goes in behind those. So very impressive, Glenn. All right, just to wrap things up, we have, last but not least, our observation reports. And of course, first and foremost, Mr. Commission.
Well, this is the double cluster in Perseus. As you notice, the cluster on the right is NGC 869, and the one on the left is NGC 884. Now the 69 is a little brighter. It's got about 200 stars in it, where the other one has approximately 100 stars in it. This was an experimental shot. Glenn LeDroux suggested that I take this, and we were to see. As you can see, I got the two pretty well, the two clusters, but I would have liked to have been able to, my field of view here is 34 minutes by 24 minutes. I wish I was just a little bit bigger. I didn't quite get 100% of both of them, but as you can see, I got the main parts of it. And that's a lovely object. It's visible year-round, so you can have a look at it. By the way, I used a 14-inch telescope and the Universe camera.
Great, thank you, Paul. All right, John Thompson. Is John here?
Christmas cards.
There you go.
Yeah, I was down to Australia for the eclipse in November, and unfortunately the eclipse didn't turn out. I've got a nice video of the clouds darkening and then brightening up again. But we also took a tour seeing part of the rest of Australia, and this was taken from the Ayers Rock Resort, which is a little village out in the desert about half an hour from Ayers Rock or Uluru itself. And I've been south of the equator several times before, but this is the first time I'd had a really good view of the two Magellanic Clouds. Those are two dwarf galaxies, irregular galaxies that are companions of the Milky Way, about 200,000 light years out. And so there's let's see, we've got the, that is 47 Tucanae, which is another large globular star cluster. It's about half a degree across. And then there's a few other star clusters. This is Carina down here. NGC 2318.
That's the Southern Pleiades.
Actually, this one's the Southern Pleiades. This one's a 2318, and then there's there's another little open cluster here, 3114. If I can find it, let's see. That star right there is the southern pole star, Sigma Octantis right there, and the pole is right about there. So one way of finding it, if you can see the Magellanic Clouds, it's more or less a equilateral triangle from the two Magellanic Clouds. But I was taken with actually a prosumer 5-megapixel Canon camera that I used this Canon software hack on to give it 64-second exposure. So that's just almost like an advanced point-and-shoot camera that was taken with, and it goes down to 8th magnitude about. Next picture. And I was also able to put a fisheye adapter on it. So this is more or less a full sky. You can see Orion here. Sagittarius is over there. You can see the sort of the Milky Way along here. There's Canis Major. The two Magellanic Clouds, there's two here. And the ecliptic goes sort of like that. There's Sagittarius. The great square of Pegasus is this grouping. It's rather distorted because of the fisheye. And then there's the Hyades and Jupiter, and Mars is down there, and the Pleiades. But it's that was a stack of 3 images using the same camera, 64 seconds.
That's it?
Yep.
Great. Thanks, John. Thank you. All right, Hugo. There you go.
Yeah, just a quick shot there of what Paul mentioned as we began this meeting. On Christmas Day in the evening, I had to go to Christmas dinner, and I had to get in my car to get there. And I looked out and said, wow, that looks kind of neat. And fortunately, since it was a festive occasion, I had my camera with me. So I'm not as fortunate as some of you who have iPhones with you, which have built-in cameras. So my camera's not always with me. Anyway, this was taken at 1/500th of a second, because it's very bright, and about 2.8 opening at an ISO of 200. And it doesn't look quite, and one of the things I found is these automatic exposures or automatic focus does not, on these cameras, doesn't work very well if you have a bright object and a black sky. So the thing seemed to refuse to focus. And I finally battled the thing, and I do have a manual override, which doesn't always work all that well. Anyway, I managed to get it. And then, because it is so bright, and when you looked up in the sky, it actually looked brighter than this. But I reduced this using a photo editor so that you could actually see some of the dark areas of the moon. So it's, but the result is that the overall effect is a little bit dim, but you can see how close Jupiter is. Okay.
Probably around 6 o'clock in the evening?
Yeah.
Yeah. Okay. Thanks, Hugo. Actually, I'm just going to back up one. Just going to back up to Hugo's shot there. Oh, where are we? So just, I've got a follow-up to this as well. So he took his at around 6 o'clock, and notice the position of Jupiter and the moon. Okay, just keep that in mind. Oscar. That's nice.
Hey, so last fall I took an astrophotography course. It was actually taught by Paul, and I got bitten pretty hard by the astrophotography bug, and I got myself an astrophotography rig. Anyway, I just wanted to present one of the first images I've taken here. It's probably familiar to most everyone here. It's the Orion Nebula and the Running Man Nebula. So I took this image with Canon Rebel T3 DSLR at 1600 ISO. It's about 58 minutes worth of data with subframes of varying lengths. What I was trying to do was capture some of the dimmer features of the nebula, but not overexpose the core. And I didn't quite get as much detail in the core as I wanted. But regardless, pretty pleased with the way the image turned out, considering that this was actually the second image I took with this particular rig. Thanks.
Excellent. Thanks, Oscar.
Did he pass the course?
Yeah, he obviously passed the course. You young pups are so lucky, I tell you. I was saying this to Oscar when I saw this. I said, "This is one of your first shots." When I was starting astrophotography back in the film days, I could only dream about doing stuff like this. You young guys, I don't know. You got it easy. Anyway, nice work, Oscar.
What caused that lighthouse effect on the two stars at the top there? It looks like
Up there?
Yeah, I was trying to figure that out. I talked it over with the guys over at Focus, where I bought my scope, and they thought perhaps there was a pinch cell in my refractor. So they took care of that for me. Because of the clouds, I haven't had a chance to go out with it again to see whether it got resolved. But hopefully it has. I'm not sure.
Okay, thanks.
Great. Nice work, Oscar. All right. Oh, wrong way. Is that you or me? No, that's you.
There.
Okay, so I also happened to have my camera with me Christmas Day. Yeah, just happened to have. Funny how that works. But I couldn't get away right at the supper hours. So this was about 3 hours later. This is about 9:30 or so. And again, you can see from Hugo's image there, he had Jupiter placed around there. That's how much the moon has moved relative to Jupiter in those 3 hours there. But yeah, it was a lucky opportunity there. So that was really pretty if you did get a chance to have a look at it. So again, remember, January 21st, we have a similar occurrence there. All right, next. Next one there. So this is a hydrogen alpha shot, only hydrogen alpha light, so that's why it's all very reddened. This is the Heart and Soul Nebula right near Cassiopeia. You can just see the one star of Cassiopeia right at the edge there. Cassiopeia would be like this on this side. You can also see the double cluster. Of course, in hydrogen alpha, the stars are very much reduced, so the double cluster isn't nearly as impressive, but the nebula sure come out, and it's much redder on this side of the frame there. This is right sort of at the edge where the Milky Way starts to get a little bit thicker as it moves through that part of the sky there, but the Heart and Soul. And for those of you that are really sick of the 80 centimeters of snow that we've already gotten, my last image is just a little reminder of the summer, and that's the warm summer nebula, the lagoon, and the Terrifid there. You know, think July, think August. You know, it's not that far away. But yeah, shot this at Starfest just last summer there. The beautiful lagoon region there, and I love the way the blue came up with the blue reflection nebula came up with the Terrifid there. So only about 5 months away. So think warm, think warm. And that's all I've got for you there. All right. All right. Just
Mike and Simon.
Mike and Simon, where are you there? Oh, there you go.
Simon, are you able to come up as well? All right. Really quickly, because I know it's the end of the meeting here, Simon and myself would like to share with you an outreach display idea that the two of us came up with. We'd like your input, and we'd like your ideas, and we're even seeking some volunteers as well. I know you can't see this right now, but you'll see a little bit more of it in the next slide here. You may remember about, I think it was at least over a year ago, I talked about really developing more professional outreach display material. So this would be in addition to, most of you have seen sort of the space truss stand that we have where we put our astrophotos on it and so forth at various outreach events like Fun Fest and so forth. I want to develop something a little more modern, maybe a little more information on them and so forth. So the idea came up again over a year ago. Now maybe we could have some sort of a banner, a vertical banner that would roll up into these tubes, and you could sort of unroll them and have a vertical telescoping stand behind it that would have information on a variety of topics. This one here was put together by Simon on the geology of the planet Mars. Perhaps we could have one on the sun, on meteors and so forth, deep sky objects and so forth. So we thought, just to sort of test the waters here, we'd come up with an idea. Maybe go to the next slide, Chris, please. And really get your input on this, because we want to go forward with this. So what you're seeing on the left here is the top half of the previous slide, and the right is the bottom half. As you can see here, and this is, by the way, Simon put this together. Simon and myself met a week and a half ago, and we discussed this ideas of our bottle of wine, and it amazed me how quickly he put this together. I think he finished the wine, we really, the next steps are here is we want to come up with some sort of a template. So we have a background here. We have some ideas in terms of how information is laid out. We're looking for people who maybe have some other ideas in terms of how we can impart information to people, visually. I'm not a graphics artist person. I don't know how things print, well when you print onto vinyl and so forth. Maybe there's some people around here who have some ideas in terms of how you can, what happens when you print to vinyl or to marketing stands and so forth. Maybe you've got some ideas in terms of where information should be placed. For example, on these vertical stands here, well, typically the bottom 2 or 3 feet, nobody's going to look at it because it's just too far down. So maybe we'll have a big, huge Ottawa Centre logo. Okay. Anyhow, I don't want to go through all this right now here. Simon and myself have a sort of a booth outside. We're looking for some ideas in terms of how we can present this information. And if you've done this before, and if you're interested in maybe putting all this together, maybe you're somebody that's good at interfacing to print shots, maybe you're somebody who's good at laying out information here, we're looking for those kind of people. And don't worry about content, because I know who to chase after in this club for information. But anyhow, that's all. And really, it's all about making our displays a little more professional, something we can show. Simon, anything else?
No, but we'll be outside to discuss with people as they're leaving.
All right, that's it. Thanks.
Thank you. All right, just a quick reminder there. Again, we're in the new year, so we're looking for new thoughts, new ideas. If you've got something that you'd really like to put together a presentation on, feel free to approach myself or Chris. We can give you a hand with it if you haven't done it before. I know a few people approached me just at the end of the year there, so I'm jogging your memories there. If you want to move forward with that and put something together, we're more than welcome. We're more than open to hear from you. So please don't be shy. We'll give you a hand. Estelle's with us tonight, so she's got the library open, and the Worlds of Galileo is her pick of the month. Excellent. Yes? Oh yes, absolutely. Our post meeting, we have our usual lineup there. We have Estelle, as I mentioned. Al isn't with us tonight, but we do have coffee and conversation with Ann and Art. You can also see Art for RASC membership info and cards. And Stephen with us tonight? Did you see? I didn't see Stephen. No. Okay.
I always do him by email to renew subscriptions.
Absolutely. The rest of the museum is closed, and we do have the after-meeting meeting at Kelsey's, and I promised Eric 10 seconds. Your clock is running. Tick, tick, tick.
DVDs are all updated, including the annual meeting that we had in November, so if you missed it, you can see it on DVD. And anyone who does a presentation gets a DVD upon request. Thank you.
All right. Thank you. That was 13 seconds, but we'll let it go. Hey, it's late, sorry. All right. We had 30. No, how many?
104.
104 people in the audience. Thanks again for everybody that contributed to supplying materials for tonight's meeting, and thanks again to the museum. Comments, complaints to me, and yeah, I'll see what I can do. Next meeting, February the 1st.
Friday, your usual first Friday of the month there, and we'll hopefully see you at 8 o'clock at that time. Enjoy your month. Let's hope for some clear skies, and thanks for coming. Good night, everybody.